Right guys, welcome back. This is going to be good. Yamaha clutch basket CP3. This is an issue that just about everybody who owns any Yamaha with a CP3 engine in suffers with. Rattly clutch basket. Now, I rebuilt these clutch baskets. I've probably done 300 plus of them with fantastic results. I'm just going to show you now what's involved in doing the basket. Right, that standard basket. If you look very closely, let me just find my little pointer. I'll point it somewhere. There we go. Right. Across this edge, it's always on this side. Probably won't focus, so you might not see it very well. You will come across a little shiny patch on the primary gear, which is only like a mil or so at the side of this plate. Now, what's that's caused by? The rubber's degrading inside there and causing the ring gear, which is driven by the crank, to move independently from the basket itself. So you end up with a rattle. They're moving backwards and forwards because the rubbers have shrunk. There's nothing to hold it secure. It's a common issue. Come on, Yamaha, get it together. Sort your shit out, please. Let's get on. This is a clutch basket. I've took out the rivets, drilled them out, pressed them out. I've done all the machining work to this one. I'm going to show you what's involved, what's inside. If we take off the retaining plate, inside you've got the rubbers. Let's see if I can zoom in and show you a bit better. Right, just watch for the gap that's created through worn out rubbers. It doesn't look to be a lot, but that's just being moved with my fingers. That's not under any engine load. So that will compound it when you've got 150, 120 horsepower up his backside. Right, zoom back out again. Right, if we lift that off, it comes off very easily because the rubbers are knackered. These are the old rubbers. Now there's a very important use for these, and that is to fill the bin. Absolute garbage. Right, inside the clutch basket, you've got a thrust washer. It's got a base ring. That base ring sits on there. Your thrust washer sits on top of there. Your ring gear sits on there, and what that does, it pushes your ring gear away from your basket so it doesn't rub and chatter. That's all that's for. Right, let's have a closer look. Get rid of those things, we don't need those. Jesus, it always fall out. I can't remember when you want them. Right then, rivets are out. What I do with these, I machine them out. I counterbore these very slightly, open them up, I cut a thread in them, and then I insert an M6 stainless helicoil. Now, a lot of people will say, well, you don't need to helicoil it, blah, 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 you can just tap it into the basket. Well, up until probably 6 months ago, these baskets were £700 from Yamaha. Why would you risk damaging a basket? If you knacker a thread in there, you've got a chance of putting a little bit of heat on it, peeling that helicoil out, and putting a new one in. Job done. It's solved. So that's why I do it that way. Longevity, that's what it is. And to me, it's the right thing to do. I've got crippling OCD, so I cannot possibly do it any other way. So right, let's put the rubbers in. First of all, don't forget the rings. Flat ring in the bottom. Conical spring washer, or your thrust washer. That goes point bit to the top. That way. Ring gear. Obviously needs a wipe off. I'm just rushing through this for the sake of time. So that goes back on there. This is where it gets interesting. This is expensive. Insint CU216 clutch rubbers. Okay. So get those out. Oh, that's why they're expensive. Get a free sticker. That's awesome. Right then. rubbers, they have to go in a certain way. So as you stand with the basket away from you, you can see the shape. I'll give it a little pointer. See the shape? It's like a teardrop shape. The wide part of the teardrop goes to the outside of the basket, which is this side. The fat side of the bush goes to the right every time. So they go in and they are a real tight squeeze because the new rubbers are not being compressed. They're really tight. Don't be tempted to put them with a screwdriver because you will knacker them. It's going to be a little bit forceful, but a little bit gentle at the same time. There. Yeah. Right, that's one in. I'll put the rest in and come back to you. Right then, we're back. They're all in. That's not easy. Try to push them in with fingers and it's about 1,000,000 degrees out there. It's absolutely scorching. Right then. Before I start putting it back together, I'm going to have a little rant really. Because this is a design flaw by Yamaha and it's really unnecessary. You know, if these guys had just got it together, you know, and thought, well, what's going to be a possible problem, and they identified this, they could have sorted it at source. You know, R&D department, they get paid millions for doing this. So why not do it? Why does it took some scruffy old bloke in the shed to sort this out? I don't understand that. Now, the problem is, as an engineer, I see how things happen. You know, you have these great ideas about stuff, and you think, yeah, that's going to work, that's going to be bulletproof, it's going to be faultless, blah, 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 it'll last forever. And that's good until that design goes through to the bean counters. Then the bean counters say, oh, what's it going to cost? They say, well, it's going to cost 50 quid. Can you do it for a tenner? And that's where you get these sort of problems. It's cost cutting, penny pitching by big companies, and it's ridiculous. They're run by bean counters, not engineers. That's the biggest problem with big companies, manufacturers, bikes, cars, whatever. It's the same sort of thing. Anyway, that's enough ranting. Let's get on with it. I don't want to bore everybody to death. It's only a second video. I don't want everyone dying on me already. Right then, retaining plate. Originally, I used to countersink these retaining plates, put countersunk bolts in, but it meant me putting countersink in the bottom of the turret, or the top of the turret, sorry, because the tape at the bottom of the bolt passed through that 2mm plate and it was hitting the top of these turrets. So I used to countersink those. Now, I don't bother because I found stainless steel button head bolts I can use, which marry up perfectly with the stainless helicals in there. So let's drop that in place. Right, bolts. Where did I put the bolts? There they are. Good quality bolts. Even though it's probably Chinesium. Everything else seems to be these days. Right then, when I put the helicals in, I normally use a high strength thread lock. I'll leave the helicals in for an hour and a half to fully cure before I run a tap down then, an M6 tap, just to clear out any excess that might seep through the thread. So once that's done, I'll start with the button head bolts. M6 by 1, 16mm long. I'll explain why I use button heads in a minute. So I'll get some thread lock on these and we'll fire them in. Oh, come on. Of course it's not coming out, it's on camera. Perfect. Right. Don't smother it, you just need a good blob on the end. So drop that in. Right, I'll get the rest in, get back to you in a minute. Right then, they're all in. Magic, love it. Right then, what I normally do, I number them 1 to 8. Opposing numbers 1, 2, 3, 4, 5, 6, 7, 8. So when you torque them up, you're applying equal pressure throughout the basket. Now before you tighten anything up, what you need to do, or what I always do, if you just eyeball it, you know, you'll see the little recesses in there. Right, from the casting, just make sure that plate is equidistant. Now, if it's a little bit too far that way, just put a small screwdriver in, just give it a little twist, tweak it down, bring it back to central. Okay, now go around, torque them up. Oh, sorry, hit you. That's because you're in the way. Right, they're torqued to 10.5 Newton meters. Opposites, the reason I number them, because I'm old and I forget where I've been. So I have to number them 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. So I can follow the numbers. I'm forgetful, but I can still count to 10 at a push. All right. Once they're done, look in the back of the basket, you'll see there's no protrusions in the back. So that's why the size of the bolts is critical. Absolutely critical. And the heads on the bolts, the reason I use button heads is because of this. If I can find a chain, I'll show you. Just bear with me a second. All right. Oil pump chain. This goes over that sprocket there, which comes down to the oil pump. That's the back of the basket when you look into the clutch housing. So that just sits in the bike that way. Now you need to make sure you use button heads, low profile, because you need to maintain that gap between the chain and the heads. If those heads are proud, you'll wipe the chain out, take out the oil pump, your engine's toast. End of. No coming back from that. Very expensive mistake. Believe me, it's been done. Not by me, but it has been done. Alright, coffee time. Right. Another thing to remember as well, when you're talking things up, you know, a lot of people think, oh, I'll crunch it up really tight and then hit it later with a torque wrench. Well, don't, because you know, you might be over torqued to start with. Just drive the bolts down, just so they're snug, you know, a little bit of resistance, leave it at that. Go and get your torque wrench. I mean, you can pick a cheap one up for about 20 quid. You know, there's no excuse for being an absolute ape when it comes to tightening things up. It's ridiculous. Because the first thing you do is strip the head out of the bolt, you might strip the thread out of the basket, and then you're screwed, you're back to square one again. And if you don't have the capability to get yourself out of jail, you're in for a long stretch, and a very expensive one. So when you're torquing up, just snug them down, get your torque wrench on, start feeling the pressure on the torque wrench, and just do it in one gentle sweep. Don't cram it down, stop, and then go again to torque it to get the torque wrench to click off, because you'll get a wrong amount of torque. Because once that bolt's gripped, you've got, what's the word I'm looking for? Oh God, I don't know. I don't know what the word I'm looking for, but that's the right thing to do anyway. Just one sweep, you torqued, job done. I'm so shit with words, it's unbelievable. I've got the words in my head, I know exactly what I want to say, but because the bloody camera's rolling, my brain just turns into porridge. It's only my second video, so you'll have to excuse me for being an absolute weapon. It's ridiculous. Right then, the clutch basket. Once it's done, just to make sure you've got everything in correctly, just there, you should have an air gap. Now, all that does, it allows you to compress the rubbers so that ring gear doesn't bind up on the basket, or the primary gear, sorry, doesn't bind on the basket. There needs to be an air gap between them. So I normally set my feeler gauges up to about 0.3. I don't know if you can see that on camera. 0.3. And then I'll systematically go round That's a little tight actually, 0.3. I'll drop down a little bit further. What have we got? I suppose it's only 0.3, surely. 0.2. Let's go for 0.2. Right, 0.2. That's quite free. So I'm estimating that gap to be about 0.25 of a mil. Yeah, that's not dragging at all. Just go around the basket in a few places. Yeah, as long as you're not dragging. Ideally, if you get 3 equidistant spacers, where you're there, on camera again, say there, there, and there, if those are roughly the same, you know it's put together properly and it's straight. Because if you've got one side that's nipped and one side that hasn't, you'll probably get vibration, it'll wear the basket out, and you're in a world of trouble. You shouldn't be if it's put together right, but it's worth checking. You know, just don't leave it to chance. It's an expensive piece of kit, and your engine's more expensive than this, so just pay attention to it. Right, that pretty much covers what we need to do to put the rubbers in the basket. I'm not going to go through the whole machining process because I don't do that here. I use a proper machine shop for that, because I'm set up for that, and it's easier that way. And it's a clean environment, and everything's set up, the jigs, everything, it's all set up. The reason I did this to start with, I bought a bike, Yamaha Tracer MT-09, fantastic bike, cracking engine, handles sweet, a little bit saggy on the back end, but you know, it is what it is. It became evident after a while that the basket is a problem. I got a rattling, especially on idle, and on and off, sort of on and off the throttle. You know, pedaling the throttle, you could feel it kind of surging a bit, you know, and that compounded by a bad fueling issue anyway. But that's a different story. We'll go into that later date. The first thing I did, being an engineer, and it was driving me absolutely nuts, I thought, right, I'm having the clutch basket out, I'm gonna have a look. So I took it out and noticed the little rub marks in the side. I thought, well, something's moving. You know, there's got to be something in there. You know, rubbers, springs, whatever. I'd never had one apart before. Never seen one before. Not this particular type, anyway. So I proceeded to machine out the rivets, press them out, took the plate off, saw the rubbers, and I was absolutely horrified at the amount of play in the rubbers. I mean, you were talking a good 2 mil. You know, the primary gear was moving a good 2 mil backwards and forwards on the rubbers. They were that worn out, totally shafted. So, well, no, I'll never do. So, after a bit of research, I found some rubbers, which were the same, turned out to be the Hinson rubbers. Bought a set of rubbers. And I thought, right then, next problem, how the hell am I going to fasten this back together? And then, you know, overnight, you kind of wake up at 3 o'clock in the morning, as weirdos like me normally do, thinking about something, and it was, well, there was the answer in the middle of my sleep. Drill them out, counterbore them, helicoil them, stainless rivets, stainless bolts, whatever. I went with the bolt issue, the bolt idea, sorry. And that was on my own bike. And I thought, right, I'll test that. So I put it all in, put it together, transformed it instantly, overnight, transformed it. So I left it in the bike, probably 50, 60 miles, took it out of the bike again, took it all apart, inspected everything, and it was as tight as a drum. There was no wear, no rub marks, no noise, no rattling, vibrations. It had all gone. So I put it back together again, put it back in the bike, probably did about 300-400 miles, and it still felt fine, but I thought, I'm going to take it out again. So I took it out again, inspected it, took the plate off, took the rubbers out, measured the rubbers, you know, checked everything, and it was fine. So put it back together again. Probably did about, what, 1,000 miles. I thought, right, I'll take it out again, just to check, because like I said before, I've got a terrible case of OCD with things like this. I need to make sure it's right. Excuse me. So after about 1,000 miles, took it apart, tight as a drum. It's now done, oh, I've no idea, thousands and thousands and thousands of miles on those rubbers, and it's been faultless. The only thing that has been driving me mad is this. Yeah, you know, the pressure plate. what the hell is that? Yeah, before you're smart ass to say, oh, it's a bearing. Yeah, I know it's a bearing, but why is it a bearing? A conventional bearing providing an axial load on the plunger. I don't understand that. Why? Another design fault by Yamaha. Bean counters again. Oh, let's do it the cheapest way possible. So, bear with me, I'm going to show you something. That is the pull rod for the clutch. That goes just behind the pressure plate. In there, attaches to your clutch release arm. So basically that pulls this way, pulls the pressure plate off the clutch pack, compressing the springs, pulling it this way to disengage your clutch. You're pulling all that load, which is not a lot, but you're pulling that load axial on that bearing. That bearing is not designed for that. So I had another idea, another 3 o'clock in the morning job, which was this. Another pressure plate. I machined out the pressure plate inside there. All you that know will know what that is. That's a race for a thrust bearing, which is designed to take axial loads. So, after a lot of cocking about, I put a few little bits and bobs together. There's a little bit of Heath Robinson at the moment, but it has been in the bike and it's been tested for a few thousand miles and it's been fine. What I had to do, I had to source the bearing, thrust bearing, so all that goes together. And then I had to figure out a way to keep that bearing together. So, after a lot more cocking about, lots more coffee at late nights, I measured up and designed that. Top hat bush. Now what that does, I have a little spring. Goes inside the top hat bush, in there. The push rod goes inside there. And the whole shebang drops inside there. So we now have a bearing designed for the job, designed for axial loads. I've had this in the bike for 2,000 miles and it's been brilliant. I had a few concerns about oil starvation, but there's enough gap around there, if you can see closely. I'll try and zoom in a bit. There's enough gap around there to get oil in, so I didn't have an issue with that. The only issue I've got is those bearings wear out. So when you engage and disengage in the clutch on the MT-09s and the Tracers, when you let the clutch out and it's in neutral, you get the vibration from the clutch basket. So we've sorted that problem, but the issue you get now is when you engage the clutch, you get a whirring, grinding noise, which is coming from this bearing. For 2,000 miles, I haven't had that noise. That's been brilliant. But the problem is, I'm a bit conflicted really, because I'm an engineer, I want to do things right, and I want to supply this service to other people, but it's not financially viable, because by the time I machine this rod down, so I need that machine down to fit through the top hat bush, I need to source the correct springs, I need to get the bearings, I need to spend God knows how much time mass producing top hat bushes. This bearing from Yamaha is about 30 quid. It's going to cost way more to do this. So now I sound like a bean counter, which I apologise for, but that's just how it is. I do get it to a certain extent. So what I've decided to do now is make up press tools. So I now have press tools that I've machined out, which fit perfectly inside there, which is a standard clutch, and they fit perfectly inside the slipper clutch. Incidentally, the slipper clutch has got the tiniest, pissiest little bearing you've ever seen. That's like a little Christmas cracker bearing. That's crazy. But it does the job for a short amount of time. This pressure plate for this slipper clutch, it's not on the parts diagram at Yamaha. Well, the plate is, but the bearing isn't. Whereas a non-slipper clutch is. You can buy that bearing from the likes of Fowler's for 30 quid. This one you can't get. It's not on the parts diagram. I've just identified the bearing. I've ordered some bearings. So one of these little spigots there fit perfectly inside there. Only issue is it has to be heated up because these are very, very tight. And if you just press that out or knock it out with a hammer in a socket, like a lot of people probably would, I'm not saying that's a wrong way to do it, but you know, you don't want to sort of stress in pieces. You need to heat that up. You need to get heat around here, expand that very slightly, a little bit of pressure with the pusher or the puller, and that will pop straight out. And then get basically rinse and repeat, you know, to put it back in. I want to do it primarily for this one because that piece is about 140 quid from Yamaha. 10 quid's worth of bearing in it. What's the point? So that's why I've done the press tools. So I do the service for the clutch baskets. That's not a problem. Now I can do this as part of the service on clutch baskets. Change the bearings, slipper clutch, non-slipper clutch. Happy days. Away we go. Thanks guys. See you soon.